Hi everyone, my name is Puneet Chaturvedi and we are presenting our AML end term project. My team members are Agastya Krishna, Andrew George Arian, and our objective of this project is developing a SMS spam filter. SMS spam collection is a set of SMS tag messages that have been collected for SMS spam research. It contains one set of messages in English of 5574 messages tagged according being HAM or spam. Flow of the project: creating data frame, text preprocessing, data exploration, vectorization, dimension reduction, model development, and selection of best model. Our first step is data preprocessing. First step is to convert the text into lower cases because converting text to lower cases ensure that same word is not treated as multiple different words, leading to more consistent data. Second step is to remove stop words because it has little or no meaning and it generally used to connect other words and it can help reduce dimensionality of the text data. Third step is to remove punctuations and special symbols as it can change the whole meaning of the word, which can impact our sentiment analysis. Fourth step is to remove white spaces as it can reduce the size of text data and improve efficiency of our analysis and helps in information retrieval. Last step is to do stemming as in word frequency analysis, different forms of a word treated as separate words. Stemming can help eliminate this issue by reducing different forms of word to a common root, resulting in more accurate results. Now we are presenting a word cloud of HAM SMS and spam SMS. Word cloud is used to identify the most frequent words and their relative importance in the text data. It helps us to divide the words in two classes, HAM and spam, so that we can easily identify which words are frequently appearing in spam emails. For classifying the spam email, we use the cloud of spam words and create list of suspicious words, which helps to create an additional feature. Pipelines for vectorization approaches. First one is bag of word model using TF. In this model, we have count the frequency of each word in the text data. A vocabulary of all the unique word in the text data is created. This vocabulary serves as the dimensions of the feature vector. For each document, a vector is created that represents the frequency of each word in the vocabulary. The feature vectors are the numerical representation of the text data in the bag of words model. The feature vectors can be used as input to various machine learning algorithms for analysis. The bag of word model provides a simple and intuitive representation of the text data, where the size of each word in the feature vector reflects its importance in the text data. Now our second approach is TF-IDF, term frequency. TF-IDF is a vectorization technique that assigns a score to each word in a document, reflecting its importance based on its term frequency and inverse document frequency (IDF). TF-IDF vectors on stem data help us to provide a more robust representation of the text data where the words are reduced to their root form and the importance of each word is reflected in its score. TF-IDF scores helps us to improve the performance of the machine learning algorithms. Now our third approach is doc-to-vec model using Google Word-to-Vec model. Word-to-Vec model helps us in getting a 300 column embeddings from a Google binary file. We make use of this embedding and add them up for each word in a document, thus getting a 300 dimension vector for each document. We end up with a 300 feature set for each document and use them for analysis and clustering. Here we have used the above approach to create embeddings to be used for spam ham classification. Now my friend Andrew will uh, present the next slide.
Friend told, apart from the structured features that we have added some heuristic features also. Namely, whether we are checking whether the first word is capitalized, whether the SMS contains phone numbers, whether the uh, SMS contains suspicious words, or whether the length of the SMS is higher than usual, or whether the percentage of stop words in an SMS is higher than usual. So by checking whether the first word is capitalized or not, we were able to see that the odds ratio of the message to be spam becomes 0.25, and the odds ratio by using the feature whether it contains phone numbers or not, that also becomes 0.25. And uh, by using the suspicious list of suspicious words, whether those are there in the SMSs, we saw that we'll be able to classify around 54.2% of the spam messages correctly. And the length of the we also noticed that the length of the SMS which are spam were greatly higher than the length of the ham messages. Dimension reduction, we have used two methods. One is through dimension reduction through PCA, one is through heuristic methods. In PCA, we have selected document term matrix, TF, IDF vectors, and doc2 vectors. By selecting a threshold of 95% of the variance, we were able to bring down the number of columns in DTM to 2523, TF, IDF to 2936, and doc2 vec to 181 columns. Another heuristic method, when we tried, we have set a threshold of 1% of the threshold of the word to be 1% of the documents, and in such a case we were able to bring down to 162. And yet another method was to check whether the word is present in at least 1% of the total number of words in the corpus. While doing so, we were able to bring down the number of columns to 33, which is a great reduction when compared to the earlier methods. This We have done a visualization of the PCA components. We have selected the first two PCA components. We have got the graphs as given here. The PCA components for DTM as well as TF, IDF, and doc2vec are as given here, and the yellow ones show it is a spam message, and the blue dots show that it is a spam ham message. We have fitted several models on the features that we have got earlier, and they have been mentioned in the slide here. The top 10 models were found to be the ones marked here, and these will be discussed in detail by my friend Agastya Krishna.
And as you said, we had fitted several models on this classification problem. These are namely decision tree, random forest, logistic regression, gradient boosting method, ADA boost, backed random forest, KNN, and support vector machines. Our aim of the experiment was to see how stemmed vectors with heuristic features help in predicting spam with these eight models. We used accuracy, precision, recall, and F1 score as our metrics. Logistic regression actually perform best with these features, which give a minimum score of 90% on recall when we used it on validation data. It is the highest scoring F1 metric model among the models which we have fitted here, which is surprising considering it is a very basic model. Random forest fitted on the features mentioned here gave a recall of over 88%, and it was placed second when we grouped it based on F1 score, which was over 93%. When we fitted STEM TF vectors with logistic regression, it gave over 87% score on recall, and it was placed third rank based on F1 score, which was around 93%. ADA boost performed slightly worse than logistic regression, which had an F1 score of 92%. M vectors, when reduced with heuristic features with backed random forest, gave us a performance of 92% of F1 score, which is, considering it is a reduced vector, it is a good performance. Logistic regression on the similar feature we said just before gave us an F1 score of 92%. Gradient boosting method on stemmed vector reduced gave us an F1 score of 91% and recall of 85%. F1 score is actually slightly lower than that of logistic regression. We fitted AdaBoost model on stemmed dog-to-vec model with heuristic features. We got an F1 score of 91% and recall of 88%. Logistic regression, when we had fitted it on stemmed dog-to-vector features, it gave us a recall score of around 88%, and performance in F1 score was around 90%. It ranked 9th among top 10 places we had fitted for models. And TF vectors, which is highly reduced with heuristic features with backed random forest. Highly reduced as in we have only 33 columns in this case. In that case, backed random forest gave us a recall score of over 85%, and performance among the F1 score was 90%, which is good considering we had only 33 columns. Just now we saw top 10 models we had fitted for our project. So based on these data sets, and these are the models we had used for fitting on all of these. Our next slide will be presented by Andrew.
Out of the 64 models that we fitted, it was surprising to see that the model with only 5 heuristic features gave an F1 score of 0.86 and with the random forest bagging classifier. Comparing the vectorization features, out of the top 10 models, 3 had stemmed TF vectors, 4 had reduced stemmed TF vectors, 2 had dog-to-vec embeddings, and 1 with highly reduced stemmed TF vectors. The reduced TF vectors had 161 components and highly reduced vectors had only 33 components. Out of the top 10, 7 had heuristic features in combination with the TF vectors and reduced them TF vectors. We also noticed that TF-IDF did not even come up in the top 10 models with any of the classifiers. The top F1 score achieved with TF-IDF vectors was 0.87 on validation data at a rank of 24 out of the 64 models that we checked. The worst model out of the 64 was given by TF-IDF with 500 classifier with a F1 score of 0.28 on validation data. Now comparing the model classifiers, the top 10 models had majorly tree-based classifiers and logistic regression models. The bottom models were 5N and SVM classifiers. So coming to the best model and test results, the best model after hyperparameter tuning turned out to be logistic regression model on stemmed TF vectors and heuristic features. The test result is as follows, with an F1 score of 0.944, precision score of 0.985, recall score of 0.906, and a total accuracy of 0.985. The test results are in the same range as that observed in the validation and training data, which indicates that there is no overfitting. Thank you.